Open freezer cases in supermarkets waste more energy than almost any other piece of commercial equipment in the United States. Stores know this. They've known it for decades, and they still rip the doors off. That choice is not an accident. It is a deliberate, expensive, thoroughly researched decision, and the reasoning will change how you see every grocery store you walk into for the rest of your life. Here's what you're going to learn. Why the open case actually sells more product. What an air curtain is and how it works. Why adding doors often costs more than it saves. What happened when a major chain ran the numbers and added doors anyway, and where this same logic shows up in design you'd never expect. The open freezer case dates to the 1950s. Before self-service grocery stores, you asked a clerk for what you wanted. Frozen food was new, strange, and unfamiliar. Retailers discovered early that if you made customers touch a door handle, open a glass panel, and peer into a fogged-up case, they bought less. The barrier was psychological, not physical. Clarence Birdseye had already figured out how to freeze peas. The next problem was getting Americans to actually buy them. Removing the door was a merchandising decision first, and an engineering problem second. The industry built an entire refrigeration architecture around keeping things cold without any physical barrier at all. That architecture is more clever than most people realize. The core technology is called an air curtain, and it is the reason the frozen pizza stays at 0 degrees Fahrenheit, even though there is nothing between it and your hand. A fan array at the top of the case blows a continuous sheet of cold air straight down across the face of the opening. That air sheet hits a return grill at the bottom and gets pulled back into the refrigeration coils. The result is a moving wall of cold air that acts like an invisible door. Warm store air tries to cross that boundary and mostly fails. The key word is mostly. Air curtains are not perfect seals. Some warm air infiltrates. Refrigeration engineers call this entrainment, and a well-designed open case is built to handle a predictable infiltration rate. The coils are oversized specifically to compensate. A typical open multi-deck freezer case, the kind holding ice cream or frozen entrees, runs its compressor harder than a closed case would need to. It uses roughly 40 to 50% more electricity per foot of display space than a comparable case with glass doors. Grocery stores know this number exactly. It shows up on every utility bill. So why not just add doors? Some chains have. Whole Foods began a systematic door addition program in the early 2010s. Target retrofitted hundreds of stores. The energy savings are real, typically 30 to 40% reduction in that case's electricity draw. But the economics get complicated fast. Retrofitting an existing open case with glass doors costs between $3,000 and $8,000 per door section, depending on the refrigerant system and store layout. A mid-size supermarket might have 60 linear feet of open freezer. That's a capital expense that takes years to recoup, even with lower utility bills. And then there is the sales data. Retailers tracked what happened to frozen food sales after doors went in. The numbers were uncomfortable. Some studies showed a sales drop of 8 to 12% in categories directly behind the new glass. Customers hesitated. They read labels less. The tactile friction of opening a handle, small as it is, suppressed impulse purchases. For high-margin frozen categories like premium ice cream or appetizers, that margin erosion could outpace the energy savings. Stores had to make a business case, not just an environmental one. Here is the deeper reason open cases persist, and it goes beyond energy math or sales psychology. The entire store layout, the lighting plan, the shelf height, the product-facing strategy, all of it was designed for an open case format. Lighting inside an open freezer case is positioned to illuminate product from the front, close up, in the customer's direct sight line. The moment you put a glass door in front of that, you introduce glare, reflection, and condensation. Older stores especially struggle with this. The glass fogs when a warm customer opens it repeatedly on a humid August afternoon. The hinges require maintenance. The door gaskets degrade and actually cause worse energy performance than an air curtain if they're not replaced on a rigid schedule. The open case, paradoxically, has fewer moving parts that can fail. It is a simpler system at the store operations level, even if it is a more complex one at the physics level. The real failure case is instructive. In 2013, a European grocery chain, Migros in Switzerland, completed a full store retrofit with doors on all open cases as part of a sustainability initiative. Energy bills dropped as projected. But within 18 months, 3 of their retrofitted pilot stores reported a measurable uptick in refrigeration service calls. The door gaskets in high-traffic sections were failing faster than the maintenance schedule anticipated. In one store, a failing gasket on a freezer door went unnoticed for 11 days, running the compressor in that section continuously at near maximum load. The energy cost of that 11-day failure erased roughly 4 months of savings. The case became a training document in refrigeration engineering circles about the difference between theoretical efficiency and operational efficiency. A system that is 40% more efficient but requires perfect maintenance is not always better than one that is less efficient but nearly self-correcting. This same trade-off between theoretical optimum and operational robustness shows up everywhere once you know to look for it. It is why airplane tires are inflated to 200 psi and replaced on a fixed cycle, rather than monitored continuously. It is why highway rumble strips are a physical groove rather than a sensor system. It is why the best bicycle commuters often use single-speed bikes. Fewer components to degrade means more reliable performance in real-world conditions. The principle is that open architecture with a known, manageable loss often beats closed architecture with a catastrophic failure mode. The open freezer case is not laziness. It is not ignorance. It is a century of refrigeration engineering, consumer psychology research, retail margin analysis, and maintenance scheduling all arriving at the same uncomfortable answer. The system that wastes a predictable amount is often more reliable than the system designed to waste nothing. Next time you reach into one of those cases and feel that curtain of cold air push back against your hand, that is not a design flaw. That is the design. If this is your kind of thing, the why behind the everyday object theory drops new ones Monday, Wednesday, and Friday.